Hi students. So in our previous video, we have came across the composition of the function and invertible function. So now let us move to the exercise 1.3, which is purely based upon the composition of functions and the invertible function. So in that first question, they have given let f be a function from the set 1, 3, 4 to the set 1, 2, 5 and g be the function from the set 1, 2, 5 to the set 1, 3. And they have given a function in the form of an ordered pair, function f and the function g, and they have asked us to write down what is gof. So if the function they have given in this ordered pair means, what does that implies means f of 1 is equal to 2, f of 3 here, f of 1 is equal to 2, f of 3 is equal to 5 and f of 4 is equal to 1. Similarly here also g of 1 is equal to 3, g of 2 is equal to 3 and g of 5 is equal to 1. This is what the meaning when the function f is or a g is given in the form of an ordered pair. So now what they have asked, they asked us to find the gof. So gof of x means what? It is nothing but g of f of x. So what we are going to take here, x value, those values which is satisfying the function f. So which are the values satisfying the function f? These set, that is 1, 3, 4, this set satisfies the values of the function f. So the input value or the x we are taking from which set? We are taking from the set which satisfies the function f. So let us start. G of f of 1. So g of f of 1, it is nothing but g of f of 1. So what is f of 1 here? F of 1 is equal to 2. So it is nothing but g of 2. So what is g of 2? G of 2 is equal to 3. Similarly, gof of 3, because the input is from the set of the domain of the function f. So gof of 3 means it is nothing but g of f of 3. So what is f of 3? F of 3 is 5. So g of 5. What is g of 5? G of 5 is 1. Next, gof of 4. Gof of 4 is nothing but g of f of 4. So what is f of 4? F of 4 is 1. So that is nothing but g of 1. What is g of 1? G of 1 is 3. So gof is nothing but these many functions. That's all. This is regarding the first question. So the next question, they have given three functions f, g and h, and that function is from the set of real numbers to set of real numbers, and they have asked us to find these two things. Okay, so let us go with one by one. So I'll consider the first one. Let us consider the LHS, that is f plus g of h. So it is nothing but if I take with respect to x means where x belongs to set of real numbers means what happens? F plus g of h of x, right? Suppose if we write f of g of x means what does that implies? F of g of x, right? Similarly here that become f plus g of h becomes f plus g of h of x, and we already know that f and g are both are the functions, and we know that from the class 11th algebra of the two functions we already learned that f plus g of x is equal to what? F of x plus g of x. This is what we learned in the algebra of the functions. So using that thing, what does this implies? F plus g of h of x becomes f of h of x plus g of h of x. So f of h of x, this means what? F of h of x plus g of h of x becomes g of h of x. So it is nothing but what? F plus g of h is equal to f of h plus g of h, which is nothing but the thing which we needed to prove. Similarly, the second one also. So here also I'll consider the LHS plus LHS thing, that is f into g of h I am solving this one with respect to x, where x belongs to the set of real numbers. So this is nothing but what? F into g of h of x. It is similar to this one itself. So in the previous class 11th, we also learned that in the algebra of the functions, that is product of any two functions, f into g of x is equal to f of x into g of x. So that only I am going to solve here, using here. So that becomes f of h of x into g of h of x. So if this implies what? F of h of x into, this implies g of h of x. So in together, what happens? F into g of h is equal to f of h into g of h. This is what we needed to show here. So that is what we have done. So this is regarding the second question. So the next question, they have given us the two functions and asked us to find Goff and Fogg. So let us, in that two questions are there, let us solve one by one. The first thing is, suppose if we needed to solve Goff. Goff with respect to what? With respect to x. Both are with respect to x only, so no need to worry about x and y in this question. So Goff of x. Goff of x means what? G of f of x. So g of x means x to the power 1 by 3. G of t means t to the power 1 by 3. G of f of x means what? F of x to the power 1 by 3. Okay, what is f of x? F of x is mod x. So what happens? Mod x to the power 1 by 3. This is Goff of x. And they asked us to find Fogg of x also. That is, Fogg of x is equal to what? F of g of x. Okay, f of x is mod x. F of t is mod t. So f of g of x means what? Mod g of x. What is g of x? G of x is x to the power 1 by 3. So mod of x to the power 1 by 3. This is Goff function. This is Fogg function. That's all. They asked just to find Goff and Fogg. We have found Goff as well as Fogg. That's all. Similarly, the next question, here also we need to find Goff and Fogg. First, Goff of x, that is g of f of x. G of x is x to the power 1 by 3. G of t means t to the power 1 by 3. So g of f of x means what? F of x to the power 1 by 3. What is f of x? It is nothing but 8x cube to the power 1 by 3. So I can write 8x cube as 2x whole cube to the power 1 by 3, where cube root and cube get cancels and we get 2x. This is Goff of x. Similarly, Fogg of x. Fogg of x, it is nothing but f of g of x. So f of g of x. F of x is 8x cube. F of t is 8t cube. So f of g of x means what happens? G of x to the 8, g of x to the power cube. So what is g of x? G of x is nothing but 8 x to the power 1 by 3 whole to the power cube. So x cube root of x whole cube means what happens? Cube root and cube get cancels. It is nothing but 8x. So here this thing, it is nothing but f of x is 8x cube. F of t is 8t cube. So f of g of x means we are just replacing the place where x is there. In that place we are replacing with g of x. Similarly here, where x is there, we are replacing that x with f of x. That's all with solving Goff and Fogg. And they asked us to find only this much. So this is one we have found out, Goff as well as Fogg. This is regarding the third question. So let us move to the fourth question. So in this they have given a function f of x from, that is 4x plus 3 divided by 6x minus 4, where x is not equal to 2 by 3. What does this implies means? Suppose if you take 2 by 3 means here, what happens? 2 by 3, 3 ones are 3, 2s are 6, 2 2s are 4, 4 minus 4 0. So where this function becomes what? It is not at all defined at this point, so they are taking those point outside. That's all with this indication. So function they have given, and what we need to show? We need to show f of x is equal to x, and this is the first thing. After that we need to find the inverse of the function. So let us first deal with that first thing, that is f of x is equal to x. We need to show this one. So first let us deal with this thing. So what is f of x? It is nothing but f of x. This is what f of x implies. So f of x is 4x plus 3 divided by 6x minus 4. So what is f of x? It becomes 4 f of x plus 3 divided by 6 f of x minus 4. What is f of x? F of x is the given function itself. So 4x plus 3 divided by 6x minus 4 plus 3 from here divided by 6. Again f of x, that is 4x plus 3 divided by 6x minus 4 minus 4. Now you need to solve this one. Solve this one very carefully. So 4 4s are 16x plus 4 3s are 12. Taking the LCM simultaneously, so that becomes 3 into 6x minus 4. So 6 3s are 12x minus 4 3s are 12 whole divided by 6x minus 4. This is regarding the numerator, similar to the denominator. 6 4s are 24x, 6 3s are 12. Again I am taking here LCM, so it becomes what? Minus 6 4s are 24x, minus into minus plus 4 4s are 16 whole divided by 6x minus 4. 6x minus 4, 6x minus 4 get cancels, plus 12 minus 12 plus 24x minus 24x get cancelled. So here 12 plus 12x plus 16x, it is nothing but 12 and 16, it is nothing but 28x divided by, again here 12 plus 16, it is 28. 28 get cancels, remaining is x. So what we got? f of x is equal to x. This is what they needed to show in the first part of this question. So we have showed that one. So f of x is equal to x. First part is finished. Next, what they asked us to find the inverse of the function f. So to find the inverse, so observe here clearly, we are following the two steps to find the inverse, and this step follows for whole your exercise 1.3 to find the inverse of the any given function. Same step follows, so observe here clearly. The first step is we need to find the function, the function. Here what they have given, they have given f of x is equal to what? 4x plus 3 divided by 6x minus 4. So that is nothing but y is equal to 4x plus 3 divided by 6x minus 4. So they have expressed y in terms of x. They have expressed y in terms of x. So our first step is to express x in terms of y. To express x in terms of y. After expressing x in terms of y, we will just put, or we will consider that x in terms of y has g of y. We are not g of y. We consider that function into g of y. When we express x in terms of y, we call that one as g of y. So what? Let us do with this first step. So they have given f of x is equal to 4x plus 3 divided by 6x minus 4. That is nothing but y. So y is equal to 4x plus 3 divided by 6x minus 4. So I will do the cross multiplication. 6xy minus 4y is equal to 4x plus 3. So it becomes 6xy minus 4x is equal to 4y plus 3. From this one I will take x common outside. What is remaining? 6y minus 4, which is equal to 4y plus 3. So what happens? X is equal to 4y plus 3 divided by 6y minus 4. So we got x is in terms of y. That is what we have did. So we expressed x in terms of y, and we are calling this one as equal to what? G of y. That is g of y is equal to 4y plus 3 divided by 6y minus 4. So we have considered that function where we are expressed x in terms of y. We call that one as g of y. What is the second step? What is the second step? Second step, after expressing x in terms of y as g of y, our second step is we need to show or we need to prove that fog of y is equal to iy, or fog of y is equal to y. Since we are getting same thing, this one is also equal to iy, or gof of x is equal to x, which is also equal to ix. We need to show these two parts. If we show these two parts means, then what happens? What the function we have considered, that is g of y is equal to 4y plus 3 divided by 6y minus 4. This itself becomes the inverse of the given function f. So now let us show these two things. That is f of g of y, which is nothing but what? F of g of y. So what is f of x? F of x is this one. So f of g of y becomes what? 4 into g of y plus 3 divided by 6 into g of y minus 4. So what is g of y here? 4 into 4y plus 3 divided by 6y minus 4 plus 3 divided by 6 into 6y plus 3 divided by 6y minus 4 plus 3. And solving this one is similar to the thing which we have got here. Suppose if you didn't observe means, you can see here our function f of x and g of y are both are the same function. Here our input was x, so here it was x only. Here our input was y, so here they have expressed with the y itself. So the thing what the solving part of this one, it is similar to the thing which we have already did in the beginning. So after solving we are going to get what? We are going to get fog of y is equal to y, which is nothing but iy. Similarly, gof of x is equal to x, which is nothing but ix. Do it this one, do it by yourself. Okay, so after this one we got we have showed gof of x is equal to x and fog of y is equal to y. So what happens now? Now this g of y is equal to 4y plus 3 divided by 6y minus 4 is the, this is what? This is the inverse of the function. This is the inverse of the function. Since the function f is given in terms of x, we are expressing this one also in terms of x. That is f inverse of x is equal to 4x plus 3 divided by 6x minus 4. So this is the inverse of the function, that is f of x is equal to 4x plus 3 divided by 6x minus 4. So now let us move to the next question. So here they have given the function and we need to give a reason whether the following functions have the inverse or not. Suppose if it is having the inverse also, we should give the reason. Suppose it is not having the inverse also, means we have to give the reason. So what the function they have given? They have given the function from certain set to certain set along with the ordered pair. So since it is a small set, let us deal with the mapping itself. So 1, 2, 3, 4 in the domain, and codomain it is having only 10. How the mapping is, 1 is mapped to 10, 2 is also mapped to 10, 3 is also mapped to 10, 4 is also mapped to 10. So by looking into this itself, this function is what? This function f is what? It is onto function, because codomain is completely occupied, but it is not 1 function. Because why it is not 1 function? Because every element having only one image, it is not having a unique image, so it is not a 1 function. Since the function is not 1, what does that implies? By it is not a bijective function. Since it is not a bijective function, what does this implies? It is having no inverse. Because inverse exists, I said one if and only if condition, like suppose if function is having inverse means then it is a bijective function. Suppose the function is a bijective function means then it is having the inverse. So here this is not a bijective, so this function does not have any inverse. So the next thing, similar way you can deal with this. I'll do with one thing. The next thing you have to do it by yourself. So here 5, 6, 7, 8, and here it is 1, 2, 3, 4. How the mapping is there? 5 is mapped to 4, 6 is mapped to 3, 7 is mapped to 4, and 8 is mapped to 1. So clearly this function g is what? Look into the thing whether it is having a unique image. 5 is having 4, 6 is having 3, 7 is also having 4. So 5 and 7 are having the same image, so it is not 1 function. And again, whether it is an onto function, no, 1 is not at all the image of any of the element present in the domain, so it is not an onto function also. Since it is not at all 1 as well as onto, it is not a bijective function. Since it is not a bijective, what does that implies? It is having no inverse. Similarly, you can do it for third one, but this is for yourself. Do it by yourself. Doing the mapping itself, you can find out whether it is a bijective. Suppose if it is a bijective, inverse exists. It is not a bijective means then inverse does not exist. The next thing, here we need to show that the function f from the domain is from -1 to 1 to the real numbers, and the function they have given f of x is equal to x divided by x plus 2. First thing we need to show this function is a 1 function. After showing this function is 1, we need to find the inverse of this function, where the function is ranging from -1 to 1 and to the range of this function. Range of this function means what? Here it is consisting of only f of x values only. So now first thing let us show that this function is 1 function. So first thing what? Let x1 and x2 be two different numbers. As usual in the beginning, how we used to prove generally 1 function, that method itself. So if f of x1 is equal to f of x2, what does this implies? If f of x1 is equal to f of x2, what is f of x1? x1 divided by x1 plus 2 is equal to x2 divided by x2 plus 2. So now let us do the cross multiplication. What happens? x1 into x2 plus 2 is equal to x2 into x1 plus 2. So this is nothing but x1 x2 plus 2x1 is equal to x1 x2 plus 2x2. Clearly x1 x2 get cancels. 2x1 is equal to 2x2. 2 get cancels. So clearly x1 is equal to x2. So if x1 is equal to f of x2, f of x1 is equal to f of x2, it implies x1 is equal to x2. So the function is 1 function. So the first part is proved here. The next thing is we need to find the inverse of this function. We need to find the inverse. So first step what? First step we need to find a function g. So here they have given y is equal to x divided by x plus 2, where y belongs to this what range of this function, or yes, here y belongs to range of the function f. Okay, so here they have expressed x in terms of y. Our first agenda is to express x in terms of y, that is y into x plus 2 is equal to x, that is nothing but xy plus 2y is equal to x. So I am taking x to the LHS. xy minus x is equal to minus 2y. If I take x common, means what happens? Y minus 1 is equal to minus 2y. So x is equal to minus 2y divided by y minus 1. Suppose in the denominator also, if I take minus outside, means 2y divided by 1 minus y. That minus, this minus get cancelled. So here x is equal to 2y divided by 1 minus y. So now I expressed x in terms of y. Therefore I am calling g of y is equal to what? 2y divided by 1 minus y, where g is a function from where? G is a function from range of the function f. So what is this y value? The y value we are going to get from the range of the function. So our g function's domain will become what? Range of f to what? To the set of real numbers. After inputting this one, we are going to get what? We are going to get real numbers except one point. If we get y is equal to 1, means denominator becomes 0. So r minus 1. So I am taking that number. If we input here y is equal to 1, 1 minus 1 becomes 0, where the function becomes undefined. So I am taking that point outside from the set of real numbers. So after getting the function or taking that x in terms of y has g of y, now our second step to find the inverse, that is we need to prove gof of x is equal to x and fog of y is equal to y. So let us go with first thing. Gof of x, it is nothing but g of f of x. So g of y is 2y divided by 1 minus y. So g of f of y becomes 2 times f of x divided by 1 minus f of x. So what is f of x? It is nothing but 2 into x divided by x plus 2 divided by 1 minus x divided by x plus 2. So now let us take the LCM. In the above part there is no requirement of LCM, but in the denominator we required LCM. X plus 2 minus x divided by x plus 2. X plus 2, x plus 2 get cancels. Minus x plus x get cancelled. So the remaining here is 2x divided by 2. 2 get cancels x. So what we got? Gof of x is equal to x. One part is done. Next is fog of y, that is f of g of y. F of g of y means f of x is equal to x divided by x plus 2. So f of g of y becomes g of y divided by g of y plus 2. What is g of y? It is nothing but 2y divided by 1 minus y divided by 2y divided by 1 minus y plus 2. So in the numerator again LCM is not at all required, but in the denominator LCM is required. So 2 minus 2y divided by 1 minus y. 1 minus y, 1 minus y get cancels. 2y minus 2y get cancels. So remaining is 2y divided by 2. 2 get cancels. It is y. So what happens? Fog of y is equal to y. So now we have proved gof of x is equal to x and fog of y is equal to y. So these two conditions are satisfied. Therefore g of y is equal to what? That is 2y divided by 1 minus y is the inverse of the function. This is nothing but the inverse of the function. So therefore f inverse of x is equal to what? 2x divided by 1 minus x. So this is the inverse of the given function f of x. So they have asked us to find the inverse. We have found the inverse. This is regarding the sixth question. So then now let us move to the next question. So here they have defined a function f from the set of real numbers to real numbers, and the function is defined as f of x is equal to 4x plus 3. So what the next is here, first thing is we need to show that the function f is invertible. Since after finding or showing that f is invertible, we need to find what is the inverse of that function. So let us go with the step by step. First, let us show the function is invertible. So when we say the function is invertible, when the function is bijective means we say the function is invertible. When we say the function is bijective, when the given function is both 1 1 and on 2 means we will say the function is bijective. So first thing is, to show it is invertible, we need to show it is bijective. To show it is bijective means we need to prove the given function is 1 1 and on 2. So let us prove that. The first thing is the given function is 1 1 function. So what they have given, f of x is equal to 4x plus 3. So to say the function is 1 1 means what we used to do, as usual, our general method, let x1 and x2 be two different numbers. If these are two different numbers means if f of x1 is equal to f of x2. So what is f of x1? 4x1 plus 3. What is f of x2? 4x2 plus 3. Plus 3 plus 3, it get cancels. 4x1 is equal to 4x2. 4 get cancels. We got x1 is equal to x2. So if f of x1 is equal to f of x2, then x1 is equal to x2 means then what? The function f is 1 1 function. Next, to say that the given function is an onto function. So you can check one thing by randomly. That is, if I take, this is also set of real numbers, this one is also set of real numbers, 0, -1, -2, 1, 2, 1.5, 0, 1.52, -1, -2. Suppose if you take input 0 means here x is equal to 0 means we are going to get the value 3. Suppose if you take x is equal to 1 means 4 into 1, it is 4 plus 3. So we are going to get some 7 value here. Suppose if you input -1, 4 into -1, -4 plus 3, it becomes -1. So for each value we are going to get the unique value. Suppose if you input some decimal values means you are going to get some unique value, because the set is defined from set of real numbers. So all the real numbers in the codomain is the image of one or the other element present in the domain. So it is an onto function. How we can write it is in the statement, that is, for every y which is belonging to the set of real numbers, that is here, that is in the codomain, there exist x. How that x will be? Suppose if I take y is equal to 4x plus 3 means how that x will be? X is equal to y minus 3 divided by 4. So there exists x which is in the form of y minus 3 divided by 4. There exists x such that f of x is equal to y. So suppose if you input in the place of x, if you take this value means you are going to get y. So where is that function? F of x is equal to 4x plus 3. Suppose if I input the value x is equal to y minus 3 divided by 4 means what happens? Y minus 3 divided by 4. 4 get cancels, 3 get cancels. So we are going to get y. That is what? F of x is equal to y. So the given function is what? It is an onto function. So the function is 1 1 as well as onto. The function is what now? Bijective function. Since the function is bijective, what does that implies? Inverse exists. So it is invertible function. Since it is an invertible function means what we can say, inverse exists. Now we need to find the inverse of that function. To find the inverse, as usual, our two method. First, expressing x, here they have expressed x in terms of expressed x in terms of y. So we need to express y in terms of x, and we are going to call that one as g of y. After taking that, expressing y in terms of y as g of y, then we need to prove fog of y is equal to y and gof of x is equal to x. So I think this part you can do it by yourself. First thing, expressing y in terms of x and calling that one as g of y and proving these two things. After proving these two things, what does this implies? Our function g of y is the inverse of the function, and expressing that in terms of f inverse of x, that is the thing. So I can do it by, this can be done by yourself, so do it by yourself. So now let us move to the next question. Here the function f, it is defined from set of positive real numbers to the set or a codomain consisting from the 4 to positive infinity, and the function is defined as f of x is equal to x square plus 4, and we need to show what function is invertible with f inverse of f is given by, they only given the f inverse, we need to show that itself. So first thing is we need to show f is invertible. So how we can say that f is invertible? When the function is bijective means inverse exists. So inverse exists means it is an invertible function. So first thing, f is invertible. So to show it is an invertible function, we need to show it is an bijective. So to show it is an bijective, the thing is we need to prove it is 1 1 and onto. So to prove 1 1, as usual general method, let x1 and x2 be two different numbers. Suppose if we assume x1 and x2 be the two different numbers, means then what if f of x1 is equal to f of x2, what is f of x1? x1 square plus 4. f of x2 means x2 square plus 4. Plus 4 get cancelled. So x1 square is equal to x2 square. Taking the square root on both the side, it happens x1 is equal to plus or minus x2. Since it is defined where x1 and x2 are taken from the set of positive real numbers, minus x2 does not belongs to set of positive real numbers. So what does that implies? x1 is equal to plus x2 only. There is no possibility of x1 is equal to minus x2. So what happens? x1 is equal to x2. So clearly function is what? The function is 1 1 function. And the next is we need to show this function is onto function. Again, to check for onto function, we need to feel whether how it is an onto function. So observe here clearly, the domain is set of all positive real numbers. Codomain, it is the set of all positive real numbers starting from the number 4. From 4, it is consisting of all the positive real numbers. So if you take any positive real numbers, 0 or whatever the numbers, if you start from the 0 means you are going to get the numbers which are lying between positive 4 to plus infinity only. So whatever the elements which are belonging to this codomain, all those elements are the image of one or the element present in the domain. So it is an onto function. So how we will write that one? That means suppose if you take any y which is belonging to that set, I mean to the codomain, means what happens? This y is the image of one or the other element present in the domain. So that element, this y will becomes what? This y will be equal to one or the other function, since the function f of x is defined. So what happens? Our x value, it is nothing but y minus 4 is equal to square, x is nothing but square root of y minus 4. So obviously this one is also greater than or equal to 0. So x value is greater than or equal to 0 means that is lying in the set of all positive real numbers, and whatever the value we are taking for y, it is lying from 4 to infinity, so we are not getting any negative values also. So it is greater than or equal to 0 means which is belonging to the set of positive real numbers, so all those x will be greater than or equal to 0. So how we will write for an onto function? For every y which is belonging to the to this set, that is from 4 to infinity, there exist x which is belonging to the set of positive real numbers. How that x will be? X will be in the form of square root of y minus 4 which is greater than 0. So this x, for every y which is belonging to this set, there exists a x which is belonging to the positive real numbers, such that what? Such that x satisfies the given function, and we are going to get f of x is equal to y. That is f of square root of y minus 4 is equal to what happens? The function y is given, so square root of y minus 4 whole square plus 4, because f of x is that function itself. So f of x is x square plus 4 means f of root of y minus 4 becomes root of y minus 4 whole square by 4. Root and square get cancels, y minus 4 plus 4, 4 get cancels, y. So for that value of x we are going to get y. So the function is an onto function. So now the function is 1 1 as well as an onto, therefore the given function is an bijective function. Since it is a bijective function, what? The given function is an invertible function. So we have proved now the function is an invertible. So function is invertible means what? Inverse exist. So inverse exist means now we need to find that inverse. So to find the inverse, as usual, our general step, they have given the function what? F of x is equal to x square plus 4, that is nothing but y is equal to x square plus 4, expressed y in terms of x. Now I am expressing x in terms of y, that is nothing but x is equal to square root of y minus 4. I am calling that itself as g of y. So our given function g, it is defined from where? The input value for the function g, that is y, and that y is taken from where? That y is taken from the set 4 to infinity. After inputting y is equal to 4, any number lying from 4 to infinity means what value we are going to get? We are going to get x, and where this x lies? Where that x lies in the set of positive real numbers. So the function g is defined from 4 to infinity set of positive real numbers. So we have considered the function g now. Now what we need to prove? Now we need to prove gof of x is equal to x and fog of y is equal to y. So let us prove that. Gof of x means g of f of x. So g of f of x means g of x is, that is g of y is square root of y minus 4. G of f of x becomes what? Square root of f of x plus, not plus, f of x minus 4. What is f of x? F of x is nothing but x square plus 4 minus 4. So plus 4 minus 4 get cancelled. Square root of x square, root and square get cancelled. So gof of x is equal to x. Next is fog of y is equal to y, that is f of g of y. So f of x is x square plus 4. F of g of y becomes g of y plus g of y whole square plus 4. What is g of y? G of y, it is nothing but what? It is nothing but square root of y minus 4 whole square plus 4. So root and square get cancelled. So y minus 4 plus 4. 4 and plus 4 get cancelled. So f of g of y is equal to y. That is f of g of y is equal to y. So now we have showed these two things. So now what is that implies? Therefore g is the inverse of the function. it is nothing but inverse of the function f. Therefore f inverse of y, which is nothing but g of y, is nothing but what? Square root of y minus 4. This is what they have said, right? F inverse of y is equal to square root of y minus 4. We have expressed that one and we have showed what they have asked us to show in the beginning of the question. So that's all, hence proved with the thing. So the next question, consider the function f from set of positive real number to the set from the number minus 5 to infinity, and the function is given as f of x is equal to 9x square plus 6x minus 5, and we need to show that f is invertible with the inverse what they have given. So again I am giving here only how to solve this one. I am just giving the hints to solve. Solving part is for yourself itself, because all the procedures are same which I have already explained. First thing is to show that function is invertible. To show it is an invertible, the thing is we need to show the given function is bijective. So first step or the first thing what you need to do is you need to prove the given function, that is you need to prove f of x is what? It is 1 1 and on 2. So how we are proving 1 1? By taking two different elements and assuming f of x1 is equal to f of x2. Suppose if f of x1 is equal to x2 means it implies x1 is equal to x2 means what? Then it is a 1 1 function, and by proving an onto means for every element y which is belonging to this codomain there exists a x which is belonging to set of positive real numbers means then the given function is an onto. So once it is 1 1 and onto means then the given function is bijective. So if it is a bijective means then it is an invertible function. It is an invertible function means now what? Inverse exists. So now we need to find the inverse of the function. So to find the inverse, they have given y is equal to what? 9x square plus 6x minus 5. The main thing what I am doing in this question right now is expressing x in terms of y. I am doing only this part, and the rest of the part is to do by yourself itself. Suppose if the question they have given in this form, that is in the quadratic equation form, means what the thing you need to do is you need to do completing the square. Completing the square, this process you need to follow, because if you follow this one means it will become easy to express x in terms of y. So what they have given? 9x square plus 6x minus 5. 9x square means I can write it as 3x square. 6x square becomes what? 2 into 3x, it becomes 6x. So 2ab means another b will become obviously 1, because here you are having only 6x. It is already satisfied with 2 and a. So 1 is the only thing to make these two things equal. So 1. So what happens to our b square? It will become 1 square. So if I am adding 1 means to make these two equations equal, adding 1 and subtracting 1. Along with that this one is remaining. So now if I combine these three means what happens? A square plus b square plus 2ab. So it is nothing but a plus b whole square, where a is 3x, b is 1, that is 3x plus 1 whole square. Minus 1 minus 5 becomes minus 6. So this is nothing but our y. So I have completing, by using completing the squaring process, I have did solve this equation. Now I am expressing this one in terms of x, that is y plus 6 is equal to 3x plus 1 whole square. So that is nothing but square root of y plus 6 is equal to 3x plus 1. That is now square root of y plus 6 minus 1 divided by 3 is equal to x. So now I have expressed x in terms of y. So I am calling this one as g of y. Now we got the g of y. To find the invertible, we need to prove two things, that is fog of y is equal to y and gof of x is equal to x. Suppose if you prove these two things means then this function g of y is nothing but the inverse of the function. So in main thing in this question is, suppose if they have given any question in this form means try to square, completing the squaring process, try to complete the square and then solve, or then you find or express the x in terms of y. So showing these two things you will find the inverse of this function. So this part is to yourself, do it by yourself. So in the beginning this one is also for do it by yourself part, and this one is also for yourself only. So now let us move to the next question. So in the next question they have given f is a function from x to y which is an invertible function. They only saying that f is an invertible function. We need to show that f has a unique inverse. So as I said in the previous video itself, in the questions regarding this composition and invertible function, we are learning some new concepts. So one of the concept is here. Suppose if a function is invertible means then that function is having a unique inverse. If we prove this one, this becomes a valuable or a new concept which we can imply in the future if a function which is invertible comes means. So what here they are saying, f from x to y, this is what it is, an invertible function. So with this given data we can come with different conclusion. That is, suppose they have given f is an invertible function mean what does that implies? It is an bijective function, because what I said, if a function is invertible means it is a bijective function. So it is a bijective function means what does that implies? It is both 1 1 and onto function. So these much things will come into our mind when we say a function is an invertible function. What we need to say or what we need to prove, that is f is having a unique inverse. So let us prove that by contradiction assumption. That is, suppose f has two inverses. They have said it is having only one inverse, that is unique inverse. Suppose now I am assuming that is f is having two inverse, say g1 and g2. These two are the two inverse of the given function. I am assuming it one. So if it is having two inverse, now g1 is also inverse of f, g2 is also inverse of f. So if g1 is the inverse of f means what does it is going to satisfy? It is satisfying f of g1 of y is equal to y, and it is also satisfying what? When g1 is the inverse of f, and it is also satisfying g1 of f of x is also equal to x, because g1 is the inverse of f. Another thing is g2 is also inverse of f, because that only I am assumed both are the inverse of f. Suppose if g2 is the inverse of f means what happens? F of g2 of y is also equal to y, and g2 of f of x is equal to x. So clearly I am taking this one, f of g1 of y is equal to y. This one is also equal to f of g2 of y. Now f of g1 of y, it is nothing but f of g1 of y. This is nothing but f of g2 of y. Now with the given data we know that f is an 1 1 function, because since it is an invertible it is bijective. Bijective means f is an 1 1 function. Since f is 1 1 function, what does that implies? If f of x1 is equal to f of x2 means then x1 is equal to x2. Since f is 1 1 now if I take this one as x1 and this one as x2, if we assume like this for 1 minute, that time what happens? If f of x1 is equal to f of x2, since f is an 1 1, it implies what? x1 is equal to x2. Here x1 is g1 of y is equal to g2 of y. So what happens now? g1 is equal to g2. g1 of y is equal to g2 of y means what? g1 is equal to g2. What we have assumed? We assume these two are two different inverses of a given function. but what we got in the end, those two are not different, they both are one and the same. So both are one and the same means what does that implies? That implies f function f is having unique inverse. It is having unique inverse because we started with which is having two inverses which are different thing. So starting with two different inverse, we came to the conclusion they both are one and the same. So function f is having the unique inverse. So generally if f is an invertible function means then it is having a unique inverse. So remember this one concept in your mind, which is very helpful in the upcoming topics. So now let us move to the next question. Here they have considered the function f from 1 to 3 to set a, b, c. I will call this one as x and this one as y. So, and they have defined a function f of 1 is equal to a, f of 2 is equal to b, f of 3 is equal to c. And they asked us to find f inverse, and then later f inverse of whole inverse is equal to f. So, you can see here clearly, if this one is set x, this one is set y means then it is 1, 2, 3, a, b, c. So f of 1 is a, f of 2 is b, f of 3 is c, where function is f. So clearly this function is 1, 1 as well as an onto, since the given function is a bijective, and since it is a bijective means what we can say, it is inverse is existing. So from the beginning itself I am saying if a function is bijective means then inverse exists. Suppose if it is not bijective means what happens, let us see that one. If it is 1, 2, 3 and this one is only a and all are mapped to this one, it is an onto but it is not an a 1, 1 function. Since it is a bijective means now what does this implies? F of 1 is equal to a, f of 2 is equal to b, f of 3 is equal to c. Since it is a bijective, we can say it is an invertible function. Since it is invertible, inverse exists. So how will be the inverse? F inverse of a is equal to 1, f inverse of b is equal to 2 and f inverse of c is equal to 3. Similarly, now look into, since it is a bijective function, I have done this much. Now clearly this is not an bijective function because it is not a 1, 1 function. Now you can see here f of 1 is equal to a, f of 2 is also equal to a, f of 3 is also equal to a. Now since it is not a bijective, suppose if I take inverse of this, that is f inverse of a means it is also equal to 1, it is also equal to 2, it is also equal to 3. But what I said in the previous question, suppose inverse exists means what? It is an a unique. But here inverse is having for one element, that is for one input a, we are having 3 inverses. So it is not at all a unique here. So to get a unique inverse, we must have a function which is a bijective function. So if it is a bijective means then only the inverse exists. So this is one of the note regarding I clubbed the bijective concept and that inverse exists and unique, which is the previous concept, together to give one of the important hint or note through this example. So now let us move to the given question. That is, they have given a function from 1 to 3 set to a, b, c and the function is defined like this. So here the function, they have not given some of the function like which we used to have in the previous, that is function is given in x plus 2. In this matter they have not given. They have given the function in the mapping way. Suppose if the function they have given in this way means we are considering the function g. Here suppose the function is given in this manner means suppose the function is given in this manner means what we used to do, they have given y expressed in terms of x, then we are turning x in terms of y and calling that one as g of y. This is the first step which we used to follow when the function is given in this manner. So here function is not given in this manner, it is given in the mapping manner. So what here in this manner, first we are going to consider a function g from where? From set y to x, that is a, b, c to set 1, 2, 3, and I am only defining the function. We are considering this function and we define that function as g of a is equal to 1, g of b is equal to 2, and g of c is equal to 3. With respect to this itself, I am defining this function. It is defined by myself here. After defining this function, now I am proving f of g of y is equal to y and g of f of x is equal to x. That is f of g of y, that is nothing but f of g of y. So what we are inputting here? We are inputting here from the domain of the function g, that is a. The means from this set, that is y. So f of g of a. What is f of g of a? That is g of a is 1, so f of 1 is a. So what we have inputted, we got the same thing. Similarly for f of g of b, that is nothing but f of g of b. What is g of b? It is 2. So f of 2. What is f of 2? F of 2 is b. Similarly for f of g of c, that is f of g of c. G of c is nothing but f of 3. So f of 3 is nothing but c. So we have proved that f of g of x is equal not x, f of g of y is equal to iy, where all the elements belongs to the set y itself. Similarly for gof of x is equal to x, that is f of g of y, that is the elements from the domain of the set x, that is 1, that is nothing but g of f of 1. What is f of 1? It is nothing but a. G of a is equal to 1. So similarly you can prove for g of f of 2 as well as g of f of 3. So once you prove that, you are going to get g of f of x is equal to iy. So now ix is equal to you proved these two things, means now what we can say, the function g is what? It is an invertible function. So invertible function means what? Inverse exists. So what is that inverse? That inverse, f inverse is nothing but what? The function g. So f inverse, it is a function from a, b, c to the set 1, 2, 3 itself, where f inverse of a is equal to 1, f inverse of b is equal to 2, and f inverse of c is equal to 3. So the given function g itself is the inverse of the function. In the beginning we only considered the function g and we only defined one function. With respect to that function, we have proved these two concepts. So after proving these two concepts, now we only saying the function which we defined earlier, that function itself is the inverse of that given function, and that is the inverse, that is the f inverse of the given function. Next is they asked us to find the f inverse whole inverse is equal to f. So clearly what we can say here is f inverse is equal to g, means it implies g is the inverse of f, and it also implies f is the inverse of f inverse is the inverse of g. Suppose if g is the inverse of f, means it also implies what? F is the inverse of g. So what does this is going to say? G is equal to what? F inverse. Suppose if I take inverse on both the side, if I take inverse on both the side, what happens? G inverse is equal to f inverse whole inverse. What I said, if g is the inverse of f, means f is the inverse of g. So g inverse becomes what? F. So f inverse whole inverse is equal to f. So this is how we proved the inverse of the given function, that is f inverse whole inverse is equal to f. So this is the question which is the remaining part, what we did in the last questions, last part, that itself they have mentioned in the another question format. So what we need to show, if f is an invertible function, means we need to show that inverse of f inverse is f itself, that is inverse of f inverse is equal to f. So as I said, suppose if uh, I mean the easiest way to understanding is, suppose G is the inverse of F means, if G is the inverse of F means what happens, G is equal to F inverse. Suppose if I taking inverse on both the side means F inverse whole inverse becomes, if G is the inverse of F means it also implies F is the inverse of G. So what happens, G inverse is nothing but F, so F inverse whole inverse is equal to F. So what I said here, that one is can be done with the systematically with the help of your mathematical expressions, or mean with the mathematical statement. That is what they have given, F from x to y, it is an invertible function. They have given it is an invertible function. So if it is an invertible function means what, there exists a function g from y to x such that what, g from y to x such that f of g is equal to iy and g of f is equal to ix. So f is an invertible means this function exists. So